Okay, this is section 7.3, and 7.3 is about logarithms and logarithmic functions. And the first thing we're going to talk about is exactly what a logarithmic function is. So let's look at this first thing that's on your notes. It says, consider the exponential function f of x equals 2 to the x. And then we had its inverse. Its inverse is x equals 2 to the y. How do I know that these two things are inverses? Well, we should remember that to find the inverse, you switch the x's and y's, and that's what we did. Okay, so the other thing, so first let's look at this first chart. We've just found some values for x. We start with -3, went to +3, and then when we plug them in, we found our y value. So our graph for this y equals 2 to the x is this blue graph. Okay, then we found the inverse of that by switching our x's and y's. And this red graph is the inverse of this blue graph. Now, we should remember too that anytime I have a graph and its inverse, to graph its inverse, it's reflected about the line y equals x. And here's that line. So they took my original blue graph, and to get the red one, we can reflect it about this line. Okay? Now, it says the inverse of y equals 2x can be defined as x equals 2 to the y. That's what we just said. And then it says, in general, the inverse of y equals b to the x is x equals b to the y. And in x equals b to the y, the variable y is called the logarithm of x. This is usually written as y equals log base b of x. Okay, so I always tell students logarithms are another way to write something in exponential form. Okay, so here's this first example. Okay, and if we'll look right here, it says let b and x be positive numbers, b cannot equal 1. The logarithm of x with base b is denoted log base b of x, and is defined as the exponent y that makes the equation by to the x, by equals x true. Okay, so here's the main thing that we didn't know. If I have something that's written in logarithmic form, which is this, it can be rewritten in exponential form. All right? So let's look, and I know this may be in a different order, but let's look at example 1. These are written in logarithmic form. Okay, to write it in exponential form, I'm going to rewrite this without using any logs. All right, so when I read this out loud, I read this as log base 2 of 8 equals 3. So when I rewrite this in exponential form, the first thing I need to do is identify my base. My base is 2, because remember when I read this out loud, log base 2. So my base is 2. The next thing I'm always going to look for is my exponent. Your exponent is always on the other side of the equal sign. So I'm going to go on the other side of the equal sign. My exponent is 3, and that's going to equal this number, 8. And then I can look at this. Is 2 to the third, is that 8? Yes, it is. Okay, so let's do part B. What is my base? My base is 4. My exponent is always the number on the other side, -4. And that's supposed to equal 1 over 256. So all we're doing, we're not doing any math. We're just rewriting it in exponential form. But I can check it. Is 4 to the -4 this? Yes, because 1 over 4 to the 4th, and 4 to the 4th is 256. C, what is my base? My base is 4. My exponent is 2. That should equal 16. Okay, so I'm just rewriting. This is logarithmic form, and I'm rewriting it in exponential form. So let's go ahead and look at example 2. This time, it's in exponential form. We want to write it in logarithmic form. So on A, the first thing I'm going to write down is log, and then I need to identify my base. Well, my base is 15. Remember, this number right here comes next, 3375 equals 3. Your exponent always goes over on the other side. B would be log base 4 of 2 equals 1/2. C would be log base 4 of 64 equals 3. Okay, so I'm just practicing rewriting. Um, we need to know what these parent function of logarithmic functions look like. If I have f of x equals log base b of x, it's going to look something like this. And this is when b, my base, is greater than 1. It's going to cross at the point 1, 0. It's going to have this asymptote at the y-axis. Okay, that means it's going to get closer and closer to the y-axis, but it's never going to cross it. Okay, and then it's going to go to infinity. So my domain are all positive real numbers, or x is greater than 0. I have an asymptote here. Okay, my range, it's going to go all the way down, all the way up, even though it looks like it levels off. Okay, this is the parent graph when b is my base is between 0 and 1. So it's a fraction or a decimal. Instead of rising up, it's going to go down. Okay, but if you'll notice, they both still cross at 1, 0 right here. Okay, so let's look at the last type of problem you're going to have. Anytime you see the words evaluate and you have logarithms, the first thing you're going to do is set this equal to x. So we're going to set all these equal to x. And then to evaluate, we're going to rewrite it in exponential form. Okay, so when I rewrite this in exponential form, I'm going to locate my base. Well, my base is 16. My exponent is x equals 4. Now, this is a problem like we had in the last section. I need to rewrite both sides using the same base. Well, 16 can be written as 4 squared, but I have that x there. This is 4 to the first power. So since I have the same base, I can drop my bases and set my exponents equal to each other. So divide by 2. So x is 1/2. Now, to check your work, I'm going to show you how to check this on your calculator. You will not be able to use your calculator on the test, but I'm going to show you how to check it. Okay, so on the calculator, I can enter this in my calculator. So I'm going to hit my math button, and I'm going to scroll all the way down until I get to where it says log base. And now I'm going to fill in the numbers. It's 16, log base of 16. 4 goes there, and my answer is 0.5, which is what I got. Okay, now you will have to show these steps because on the test, you're not going to be able to use your calculator on that part. So evaluate these. I'm going to rewrite it. My 3 is my base, x is my exponent, equals 81. So now I need to rewrite both sides using the same base. So I have 3 to the x equals 3 to some power. Okay, so let's figure out. 3 times 3 is 9, times 3 is 27. 27 times 3 is 27 times 3. 27 times 3 is 81. So it's going to be 3 to the x equals 3 to the 4th. So x should equal 4. All right, let's check it. Math. I'm going to scroll all the way down to my log base. So I'm going to enter in my 3 and enter in 81. Okay, we'll have one more. I have my base is 1/2 to the x equals 256. Now, anytime I want to use a base, I never want to use a fraction as my base. So I could rewrite 2 as 2 to the negative 1. And I have that x there. And I need to rewrite 256 as 2 to some power. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, 32, 64. 64 times 2 is 128. 128 times 2 is 256. So did I get enough? 4, 8, 16, 32, 64, 128, 256. 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the 8th is 256. So I have the same base, drop my exponent, or drop my bases, set my exponents equal to each other. X is negative 8. Okay, and again, if I want to check myself, math, go down, log of 1/2, whoops, 256, negative 8. Okay, so you have a worksheet you're going to do. Let me know if you have any questions.